So this is 2025 paper 1 question 7, and there's a lot of words here, but basically we have two functions. We have S of n, which is the total length of silk in each stage. N is just the stage. And then we also have a function A of n, which is the length of extra silk needed to go from the previous stage to the next stage. And A of 1 is 15.8. So basically, the way that we can interpret this is that in stage 1, 15.8 centimeters of silk is added, so the total length of the silk is 15.8. Then, in stage 2, the total length is 37.8, and we're asked to find A of 2, which is the amount added in stage 2. So basically, we went from 15.8 to 37.8. So how much did we add? Well, you can see that if you do 37.8 minus 15.8, we must have added 22, which is why A of 2 is 22. And then we can do the same thing. To go from stage 2 to stage 3, we go from 37.8 to 66. So how much did we add on? Well, if we subtract those two numbers, we'll find out how much we added on. And the answer is 28.2 centimeters. So basically, if we have 37.8 centimeters and we add on 28.2 centimeters, what we end up with is 66 total centimeters in stage 3. Then we're told that the numbers of A, they form an arithmetic sequence, and find the expression in n for A of n. So basically, if we have an arithmetic sequence, we have to figure out what the first difference is. So we have 15.8, we have 22, and we have 28.2. So basically, if we go from 15.8 to 22, how much do we have to add on? Well, the answer is 6.2. And then to go from 22 to 28.2, we also add on 6.2. So the common difference, which we usually call D, is 6.2. And then we also need to know the starting term, which is 15.8. So A is equal to 15.8. You don't have to memorize that, by the way. It's in the formulae and tables. So if you go to page 22, we have sequences in series, and it says that A is the first term and D is the common difference. This is for arithmetic. And we can see that the nth term is given by this here. They have it down as T of n. For some reason, they're writing it in this question as a function, A of n, instead of putting the n kind of lower down, but it doesn't really matter. It's just kind of like the convention of writing it. So basically, we can write that the nth term, which they call A of n, will be equal to, and if we have a look at the formula, so it's A, which is 15.8. Well, I'll write it down first. We have A plus n minus 1 times D. And then A, which is the first term, is 15.8 plus n minus 1 times D, which is 6.2. And we can just simplify that a little bit. So we'll say 15.8 plus 6.2n minus 6.2. And then if we subtract those, we'll basically get that A of n is equal to 6.2n plus 9.6. And that is the answer for what A of n is. And a way that you could check this is sub in 1 for n, sub in 2 for n, and sub in 3 for n, and make sure that it's the same as these numbers we have here, and that's a good way of checking your answer to make sure that this formula does indeed work. Part 3, we're asked to find the value of A of 100. That's very easy. We just need to sub in n equals 100. And what we're going to get is A of 100 will be equal to 6.2 times 100 plus 9.6, and you can just put that into your calculator. And you'll get 629.6, and remember this is a length in centimeters, although they weren't really strict about that in the marking scheme. They didn't even mention centimeters, but that's the answer. Then recall that the function S of n is the total length of silk, and we're told to use the formula for the sum of an arithmetic series to figure out what S of n is. So I guess the easiest way to do this is to remember that A of n is the amount that we're adding on each time. So again, we start with 15.8, then we add on 22 to get 37.8, and then we add on 28.2 to get 66. So if this is how much we add on each time, if we just add up how much we add on each time, well then that gives us the total length of the string. So basically, S of n is going to be the sum of A1, A2, ... all the way up to an. So basically we're doing the sum of the arithmetic series for A of n, and we have a formula for that here, which we can basically just sub into. So S of n, again, in here for sum, they use the n subscript. Here they're writing it as a function S of n. Again, it's just a kind of way of writing it. It doesn't actually change it. And then we can just fill into the formula. So we're going to have n over 2 multiplied by 2a plus n minus 1 multiplied by d. And then we can just sub in the values. So we have n over 2. And remember what a and d were. We had them up here from doing part 2. So I'll just bring them down here. So a, we're going to have 2 times 15.8 plus n minus 1 times 6.2. And then we just need to simplify this to get what they have in the question. So we're going to have n over 2 times, and then 2 times 15.8. That's going to be 31.6. And then we're going to have plus 6.2n. 6.2n minus 6.2 when we expand out that bracket. And then we can keep simplifying, so we're going to have n over 2, and then we can do 31.6 minus 6.2, which will give you 25.4. So we'll have 6.2n plus 25.4. And then we're going to be dividing each of those by 2. Or I guess an easier way to think about it is we're multiplying, we can expand out the bracket because there's no bracket in the question. So we're going to have 6.2n times n over 2. And we're going to have 25.4 times n over 2. So basically that's going to be 6.2n squared over 2 plus 25.4n over 2. And then we can just put that into our calculator to get that s of n is equal to, we're going to have 3.1 n squared when you divide that by 2, and then I'll have 12.7 n. And that is indeed what they asked us for. Then we're told that stage K is the first stage for which the total length of the silk is more than 10 meters. And then we use S of n to figure out what K is. Now remember that S of n gives the length in centimeters. So we don't want to solve for 10 meters, but we need to figure out what is that in centimeters. So know that 1 meter is equal to 100 centimeters. If we multiply both sides by 10, that means that 10 meters is equal to 1,000 centimeters. So essentially what we need to do is we need to find out when is the sum, or I guess the total length of the string, which is S of n, when is that equal to 1,000? Technically we need to solve when it's greater than 1,000, but I think it's easier if you do it with an equal sign, and then you can kind of just check numbers. So you use the equal to find out when is it exactly 1,000, and then you can kind of see what's the closest whole number to that. Because remember, n does have to be a whole number, because you can't have a stage 1.5, it's like stage 1, 2, and so on. So if that didn't make sense, hopefully you can just follow, if you just follow along, it should make sense when I actually do it. So if we have, this is S of n, that's what that is. And then that's going to be equal to 1,000. And we need to figure out what n is to make this equal to 1,000. So we can bring everything to one side so that then we can use the quadratic equation. So we can say that n will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. It's on page 20 of the Formulae and Tables booklet. So we can just sub in. So negative b, we're going to have minus 12.7 plus or minus the square root of b squared, which is 12.7 squared, minus 4 times a, which is 3.1, times c, which is minus 1,000, all over 2 times a, which will be 2 times 3.1. When you're putting this into your calculator, don't forget the two minuses here, the minus there and the minus there. So this will actually end up adding this term. If you subtracted this term, this is pretty big, and it'll probably be a complex number or an imaginary number. But yeah, so basically we can just put that into the calculator to get a rough value for what n is. So minus 12.7 plus or minus, and put that into your calculator. And you get roughly about 112.08. Doesn't have to be too exact, because remember, we're just getting a rough idea of what n is, and then we're going to figure out what the closest whole number is. So let's figure out what the positive answer will be. We're not going to need the negative answer, as you'll see now. So n will be equal to, and we get about 16.03. We don't have to consider the negative, because remember, n is positive, it's a natural number. And if we considered the minus case, we'd have minus 12.7 and then another negative. That would just give us a negative, so it doesn't really matter. So basically, when n is 16.03 roughly, then S of n is 1,000. So that means when n is 16, it's going to be slightly under 1,000, and you can plug in 16 yourself, and you'll see that it's slightly under 1,000. So that means the first value for which it's over 1,000 will be 17. So k is equal to 17. So again, we know it's 16.03. If you plug in 16, you'll see it's slightly under 1,000, which means that the first one where it's over 1,000 will be k equals 17. Then in the next part, we're kind of doing a different way of calculating the total length. So we have O1, O2, and O3, and this is a geometric sequence. And we're told to find O3, and we're given O1 and O2. So remember, for a geometric sequence, we're multiplying by the same thing to get the next term. So for example, if we want to go from O1 to O2, we have to multiply by some number called r. And then to get from O2 to O3, we multiply by r again, and we keep multiplying by the common ratio r, and that's how a geometric sequence works. You can also do stuff with the geometric sequence formula, but I think this is the most intuitive way to think about it, because then we can look at this equation. We know that O1 will be 0.5 times r. That'll give us O2, which is 0.53, which means that r is going to be 0.53 over 0.5, which is 1.06. So then if we want to find out what O3 is, well, O3 will be equal to r, which is 1.06, multiplied by O2, because we're multiplying by the same thing each time. So we're going to take our 0.53, and we're going to multiply that again by 1.06. And when you do that, you'll get O3 to be about 0.5618 centimeters. And again, they're not too strict about the units, but good to put it there just in case. Then we're asked for an expression in n for the total length of the first n orbitals. So you have to be careful here. O1 is just the length of this segment, O2 is the length of this segment, O3 is the length of this segment. So the total length, which we can just call Sn for the sum, or you can call, well, I think Sn probably makes the most sense, is going to be the sum of all of these. So what we need here is not basically the nth term for a geometric sequence, but the sum of a geometric series. So basically what we want is we want Sn. So we want to add up all of those lengths. And we know that our first term of these lengths is 0.5, which is O1, and the common ratio is 1.06. So we can sub into the sum of a geometric series formula here. So we have A, which is 0.5, times 1 minus 1.06 to the power of n, all over 1 minus 1.06. And we can clean this up just a little bit. So if you do 0.5 over, and then 1 minus, so okay, I'll just write this out. So we have 0.5 times 1 minus 1.06 to the n, and then we have that going to be over minus 0.06, which you can then write, and we want to be quite precise. I don't like to use decimals. You can say minus 25 over 3, so that's the 0.5 divided by the minus 0.06, times 1 minus 1.06 to the power of n. That is the correct answer, but if you want to make it look a little nicer, we can actually just bring the minus inside of the bracket, and we can say that positive 25 over 3, and then just flip the signs on the inside. So if we multiply the minus by the 1, we're going to get minus 1, and we'll have plus 1.06 to the power of n. So kind of a nicer way to write it is 25 over 3 times 1.06 to the n minus 1. But again, if you wrote it as this here, that's perfectly fine and valid. So this part's really confusing, but basically there are 18 orbitals in each lap, and we're asked to write an expression in k for the total length of the first k laps. So a good general problem-solving technique is to write out some numerical examples, and that can generally help you. So remember, an orbital is just this little segment of string, and then when we add up the 18 of those, we get a lap. So then if we add up 36, we get 2 laps. So let's have a look at, I suppose, some examples, and that'll help you to kind of come up with a way of doing the question. So we look at lap 1. How long will that be? Well, basically, that's going to be 18 orbitals added up. So we're going to have n equals 18. I'm actually going to take this formula. Makes more sense. So we're going to have n equals 18 here, right? So I'll write that down the side. So because we're adding up 18. Then for 2 laps, well, that's going to be 18 times 2. We're going to have 36. N equals 36. So again, we're going to have this formula, except instead of adding up 18, we're going to add up 36. And that'll give us 2 laps. If we had 3 laps, so again, I'll write lap 2, lap 3. If we had 3 laps, we'd have, well, 18 plus another 18. That'll give us 54. So hopefully you can see a pattern here. So after k laps, how many are we adding up? We're going to have 25 over 3. They're going to have 1.06. And then you can see here we have 18. Then here's 2 times 18. Here's 3 times 18. So after k laps, we're going to have 18k. Again, because we're basically 18 for 1 lap, and then if we have 2 laps, it's going to be 2 times 18. We're adding up we're adding an extra 18 each time by increasing k by 1. And that basically gives us an expression for the total length after the first k laps. Hopefully that was understandable, but I know that a lot of people did find this question very difficult.